Today we are going to discuss about block reduction technique in control system subject. So block diagram reduction. So before going to the problems, we'll discuss some of the rules which are going to take place in block reduction technique. So here you can see R of S is the input and C of S is the output. These are the signals, right? So here I told R of S is the signal, that is input signal, C of S is output signal, the middle open loop gain, that is nothing but a system here. For example, a fan, we are giving input, we are getting the output, we are giving supply, so the blades are rotating, we are getting cool air, right? So that is one system. So open loop gain will be a system, right? Similarly, we'll discuss summing point. So there are three inputs are there which are going to one output. So output is C of S, which is equals to R of S plus R2 of S minus R3 of S, as the symbol is minus, so minus R3 of S. Okay, this is the output. We are having three inputs. The same thing we can write in this format also, pick off point. R of S, R of S, R of S. Instead of this, we are using this summing point for block diagram reduction. Then cascade. See here, R of S into G1 of S. So that we are mentioning it as X2 of S. So into G2 of S. So X1 of S will be G2 of S into G1 into R1 of S. Multiply with this term. Again G3 is there, so this whole term will be multiplied with G3. That will be your final C of S. So R of S is equals to this all thing G1, G2, G3, right? So this is cascade. Similarly, parallel connection. So X1, X2, X3, right? So G1 is open loop gain. So R into G1 of S, that will be considered as X1 of S. So R into G1, R into G2, R into G3. So here summing point is there. So it will become addition or subtraction. So RG1 plus or minus RG1. So input no. So only we are considering gain. So C of S is equals to G1 plus G2 plus G3 whole bracket R, right? So we can write in this format also, R into G1 plus G2 plus G3. If it is parallel connection, we need to add or we need to subtract depending upon the sign we are having. Similarly, block diagram algebra for summing junction or summing point. Here R of S input is there, X of S input is there, both are going towards the output, but it will be multiplied with this G of S. So R G of S plus X G of S. The same thing, similar way we can write it as this G of S will be multiplied to both the inputs. Both are going towards this G of S only, R into G of S plus X into G of S. That will be our output. So instead of that, what we can do is we can take this G of S and we can multiply it to both. See here. Similarly, R G of S minus X of S. So in a similar way, what we can do is G of S we can take it outside, but here there is no G of S, so it becomes 1 by G of S, right? So that will get the same output. So such type of modification can be done in your block reduction technique. Now R into G of S, here R of S, here R of S. There is no terms are there to multiply, right? Similarly, if I take G of S here, then 1 by G of S to both sides, then here it will be no G of S, right? So similarly another example. So R of S into G of S. So here we'll get R into G, R into G, R into G. But if instead of this, we can put here also, right? Similarly, so in the previous slides we discussed about rules to reduce the block diagram, but here there is some procedure we need to follow. That combine all cascade blocks, combine all parallel blocks, eliminate all minor or interior feedback loop or internal feedback loop, shift summing point to the left, shift takeoff point to the right, repeat step 1 to 5 until canonical form is obtained. Canonical form is internal feedback loop, the same thing. Okay, so we'll take one example. So we are having theta 1 as the input, theta 4 as the output. So in middle term, G1, G2, G3, these are the signals. Theta 2 and theta 3 are the signals. So here we can reduce this. We can multiply, right? Blocks connected in series, G1, G2, G3, theta 1 by theta 4. So transfer function will be theta 4 by theta 1, which is equals to G1 means theta 2 by theta 1, G2 means theta 3 divided by theta 2, G3 means theta 4 divided by theta 3, right? Similarly, another example, R of S is there, the input is going towards the output, from output again it is coming to input, internal feedback loop. See, input it is going to output, from output again it is coming to input only. So this it is called as interior feedback loop or internal feedback loop. So we already derived this one. So G of S divided by 1, signal is minus, so opposite sign 1 plus G into H. Another example. So here we can see one block diagram is there. Here first blocks connected in series, block connected in parallel, internal feedback loop. Right, internal feedback loop is available. So solve that. G2 divided by 1, minus is there plus, so 1 plus G2 into H of S. So this whole term will be reduced and it will be multiplied with G1, right? So R by C, we got it. So another example, see here. So shift the takeoff point to the right side. Okay, so instead of, we can shift this takeoff point to the left also, but in the procedure they had mentioned that as far as possible shift the takeoff point to the right and summing point to the left. So here what I will do, I will take this takeoff point to the right side. Even we can take the summing point to the left also. Like that also, if you solve the problem, then we'll get the correct answer. So shift the takeoff point to the right, right? So this H1 divided by, it is jumping this G3, right? Jumping this G3. So this becomes series internal feedback loop, right? G2 G3, then G2 G3 divided by 1 plus G2 G3 H2, that will be multiplied with G1, again internal feedback loop, right? You can see it, C by U, the last transfer function. Similarly, we'll solve another example. So this is one block diagram is there. Here we are having internal feedback loop. From input it is going to output, from output again it is coming to input, internal feedback loop. Solve that one. So this will becomes open loop gain, this becomes feedback. So G1 divided by 1 plus G1 into G2 plus, because it is minus sign is there, right? So that will be multiplied with these two terms, right? Then internal feedback loop. See here. Input it is going to output, from output again it is coming to input only. So internal feedback loop. So we'll get this transfer function. So another example, you can see the question. So we are having many feedback lines. So this can be merged into single block, right? Minus H1 plus H2 minus H3, right? Then internal feedback loop, then that will be multiplied with this G1. So you will get this transfer function. So this is another example. So this can be reduced, internal feedback loops. Yes, it is reduced. Then about here, we need to shift this takeoff point to the right side or this takeoff point to the left side. We cannot jump summing point after the takeoff point. We need to apply critical rule, so it becomes very difficult. So easy method is to shift the takeoff point to the right or takeoff point to the left side. So as per the procedure, I will take the takeoff point to the right side. Okay, I took the takeoff point to the right side, so it becomes 1 by, there is no term, means 1 by G2, right? So this will be reduced, that is 1 by G2 plus 1, there is no term, is plus 1, right? So this is internal feedback loop, G2 divided by 1 plus G2 into H2, that will be multiplied with G1, then again internal feedback loop. See, so I used another method. So after this making parallel, this both are feedback lines, no? So I can merge that one. Here I took summing point behind the block, so it becomes H2 by G1. Then I added both the lines, right? I added both the lines. It becomes parallel. So adding both feedback lines. Then internal feedback loop. Then you will get the transfer function. Instead of that, this step you can solve like this also. This becomes parallel 1 by G2 plus 1. This becomes internal feedback loop G2 divided by 1 plus G2 into H2, right? This reduced block will be multiplied with G1, again internal feedback loop. So to this internal feedback loop will be multiplied with this reduced block and this reduced block. Only multiplication, and it's quite simple. So it depends upon you how you are solving the problem. Thank you.